Hello, my name is Nick Desjardins, and I am a portfolio manager with Canso. Before working at Canso, I served as an aerospace engineer in the Canadian Air Force. As such, I worked on various flight lines, but was also employed at the Canadian Space Agency as a robotics instructor, where I taught astronauts and mission controllers how to operate the Canadarm on the International Space Station. I believe we have a very successful history of finding value and investing in space at Canso. And the reason behind that is we were quick to recognize that the industry is in turmoil. Because of the complexity and the costs involved with sending an object in orbit, space has traditionally been left to governments and traditional satellite operators. But things are changing very fast. For one thing, advancements have resulted in a significant reduction in the cost of satellites. This has obviously opened the door to new startups. Satellite launches have also become a lot cheaper. Between 1970 and 2000, the average cost to launch an object into space was almost $19,000 per kilogram. Because of advancements in launch vehicles, that cost has dropped to approximately $3,000 and is even expected to fall to $500. Taken together, the combination of advancements and reduced launch costs have improved the feasibility of many space-based activities and revived investments in space. To that effect, the global space economy is expected to expand from about $1.1 to $1.5 trillion annually in the next 20 years. Naturally, some of this growth will be led by governments, but some of it will also come from commercial investments. In fact, investments in space have already hit record levels last year, reaching an all-time high of almost $9 billion, which is a 50% increase compared to the year before. Government budgets for space have also reached an all-time high of $83 billion last year, which is a 10% increase over 2019. Now, to put those numbers in perspective, last year alone, the FCC received requests for over 80,000 new satellites. The first commercial satellite service mission was completed. The first private rocket reached the International Space Station. The C-band spectrum auction in the US drove 13 new communication satellite contracts, and almost 1,300 satellites were launched compared to 800 the year before. Satellites can take many different forms. One way to differentiate between them is to classify them in terms of the altitude of their orbit. 60% of operational satellites today orbit around the Earth in a region called Lower Earth Orbit, or LEO, which encompasses orbits up to 2,000 kilometers. This is where you will find Hubble, the International Space Station, and the former Space Shuttle. Given its proximity to the Earth's surface, LEO is also well suited for weather and Earth observation satellites. Now, there's also a very special orbit at an altitude of 36,000 kilometers above the equator called the geostationary orbit, or GEO for short, where satellites appear to be stationary above a given point on Earth. This is due to the fact that GEO satellites spin around the Earth at the same rate as the Earth rotates on its axis. Therefore, to someone on Earth looking up, the satellite appears as a fixed point in the sky. Now, satellite TV providers were very quick to take advantage of this perceived fixed position by keeping their customers' antennas aimed at a fixed point in the sky instead of having to track a moving satellite. Finally, the region between LEO and GEO is referred to as medium Earth orbit. There's very little to say about this region because it is pretty much a catch-all between LEO and GEO and does not have any real distinguishable properties. Obviously, the further away from Earth a satellite is, the better its view of our planet becomes. At 36,000 kilometers, a GEO satellite has a broad view of the Earth, while at under 2,000, a LEO satellite has a very limited view. So for example, a well-placed GEO communication satellite can in theory broadcast over North America and South America at the same time, which would be impossible for a LEO satellite. GEO satellites, however, are very expensive. Including launch, a GEO satellite can cost upwards of $500 million. This means that it usually takes 10 years for a fixed satellite operator to recover their costs, which is why they are built to last 15 years on average. As a result, GEO satellites are contracted for their entire 15-year life. When one of these satellites approaches the end of its life, contracts are renegotiated and a new satellite is ordered to replace it. This entails that fixed satellite operator revenues and expenses are, or at least were, very predictable. However, along the way something happened. Households found new ways to watch TV. This led to cable and satellite TV cutting, which in turn has destabilized the fixed satellite operator's business model. To make things worse, satellite constellations are also becoming more feasible. Now, simply put, a satellite constellation is a number of satellites working together to maintain complete coverage of the Earth's surface. The number of satellites required to do this depends on the constellation altitude. Because of their higher altitude, a minimum of 3 GEO satellites are required to maintain complete coverage. Obviously, the lower the altitude, the more satellites are required. In the 1990s, a number of satellite constellations like Iridium and Globalstar raised billions of dollars to launch hundreds of satellites in orbit. Sadly, these constellations went bankrupt because of one fundamental error. They all grossly overestimated the demand for satellite communication. Yet, despite these failures, it appears again as though a new generation of startups wants to relive the errors of the past. At last count, there are close to 10 proposed constellations vying to be the first to offer broadband internet to the world. For example, Starlink has committed $10 billion to launch a constellation of 12,000 satellites, and Telesat has committed $5 billion to launch their very own constellation of 300 satellites. Now, if there is one thing that investors should recognize, is that markets hate uncertainty. And I think no one can argue that there is not a lot of uncertainty in the commercial space sector at this time. However, investors should also recognize that with uncertainty comes a potential for outsized returns. The way I look at it right now, fixed satellite service operators are caught in a perfect storm between cord cutting and constellation euphoria. For one thing though, despite the cord cutting phenomenon in North America, other parts of the globe are still relying on satellites. Countries that did not take part in copper cable and fiber optic cable laying over the last half century are now trying to catch up to their growing need for communications. GEO satellites are still a very viable option for these countries and have therefore been a focus of fixed satellite operators for the last decades. Fixed satellite operators have also responded to cord cutting by launching satellites designed to meet our increased need for broadband. And this is where I think it gets fascinating, because outside of Telesat, not one fixed satellite operator has jumped on the LEO constellation bandwagon. So just like in the 1990s, the one industry that really should be driving this new initiative has decided to stay on the sidelines. Other than space being fascinating, given what is taking place in the industry in terms of advancements, our constantly growing need for communication, and the somewhat outdated business model of fixed satellite operators being pitted against a renewed interest for commercial satellite constellation, I hope that I was able to convince you of why space is a worthy consideration from an investment standpoint. Thank you.